Today we're going to talk about reflections, which is another isometry. Remember, isometry means a transformation that doesn't change in size or shape. So we're going to talk about reflections. Reflections are a transformation where it flips, the shape flips, the image flips over. Flips is, if you look, the reflection, FL in reflection is your remembrance to that the object flips over. So imagine you have a piece of paper, you lay your hand on the table and you flip it over. So you take it from palm up to palm down. That is a reflection. You know what a reflection is. You look in the mirror and you see everything is opposite. If you were to lay a mirror on a piece of paper, you would be able to see, it's like you fold it along that line of symmetry or that line of reflection. So it flips over a line of reflection so that it is symmetrical, which means the same on both sides. So that line of reflection is also called a line of symmetry. And it is the line about which we flip the shape so that it is equal on both sides. So the notation, we'll write our rules just like we did before with translations, where we say how X and Y changes. Another way that you can see it is it'll be this capital R with a subscript, and then this is the object that's changing. So the M is the axis, so it might look like this, R, might say R and then x-axis, or it might say R, y equals x, and then it could say triangle UVW or ABC or whatever it is. So what that means is a reflection across y is equal to x of triangle UVW. So that's just the notation, one notation that you could see. So let's take our original shape. Our original shape, or remember our pre-image for DEF. D originally is at 4, -2. E is at 7, 4. And F is at 8, -4. So we want to undergo a reflection across the y-axis. And so basically what we're doing is we're going to take this shape and we're going to flip it over this y-axis. And so when we do that, we're going to be equidistant from the line of reflection or the line of symmetry. So D is 1, 2, 3, 4 away from the line of symmetry. So it would be 1, 2, 3, 4 on the other side. So my new D, my image of D, is right there at -4, -2. My image of E is 1, 2, 3, 4, 5, 6, 7 away from the line of reflection. So it will be 7 away from the line of reflection on this side too. And so my new image for E will be at -7, 4. And then F is 8 away from the axis, and so it will be 8 away on the other side. So it will be right here, that's F prime, my image of F, and it will be at -8, -4. Now, notice what happened. Look at my X values for -4, and look at my Y values, -2, 2. So I maintained the same height off of the x-axis. My y values stayed the same, but my x values flipped over and became the opposite. So when I flip over the y-axis, my x and y my x becomes the opposite of what it was, and my y value stays the same. That's the rule. That's the way, if you want to follow a rule, you can always count it out on graph paper, but it's quicker to know the rules. So let's go back and look at this again. So now we want to flip it over or reflect across the x-axis. So here is the x-axis. So D is going to be equidistant on the other side. It's going to flip over the x-axis, so we're going to flip it this way. And notice anything that's up is going to come down. So D is 2 below the x-axis, so it's going to flip up and become 2 above the x-axis. So it will be at a point of 4, +2. E the image of E is a 1, 2, 3, 4 above, so it will go to 1, 2, 3, 4 below. So there is my image of E. It is at 7, -4. And then F is 4 below, so it will go up to 4 above. There's my image of F. So it is at 8, -4. Or excuse me, 8, +4. Because it went up. Now, again, if you notice, look at your x values and your y values. In this case, when I flipped over the x-axis, my x values stayed the same, but my y values became the opposite of what they were. So as we change our x, y, it will become, my x values will stay the same, and my y values become the opposite. Negative means opposite, not it becomes negative. It means it becomes the opposite. Notice F originally, the pre-image of F was negative. It had a negative y value, so it became positive. But the pre-image of E had a positive value, and it became negative. So it becomes the opposite of what it was before. Now, we can also reflect across y is equal to x. You can reflect across any line, and we're going to talk about several. Well, y is equal to x is this line right here, this diagonal with a slope of 1/1. So if I take my original point, my pre-image of A is at 2, 1, B is at 6, 2, and C is at 4, 5. And we want to flip across. So imagine folding this paper in half along that diagonal. Then A, the image of A will go here. There's my image of A. B, which was at 6, 2, will go over here. There's my image of B is at 2, 6. And C will go to 5, 4. Now, if you notice, it's interesting to note that if I were to connect A to A prime, B to B prime, and C to C prime, notice that the slope of those are perpendicular to the slope of y is equal to -x. So if the slope, or y is equal to x, the slope of this line was 1, then the slope of those lines that are perpendicular, which gets us our new point, is -1. So it's just an interesting fact. Not anything that it might help you to remember how to do it if you forget the rules. So the rule for this then, if I'm going to switch over y is equal to x, notice y is equal to x and x is equal to y. So what happens is my xy originally is this x is equal to y, and this y is equal to x. That's what the statement says. It tells you exactly what's supposed to happen. Y becomes x, and x becomes y. You just switch them. Now, for the next one, we have y is equal to -x. Now, you could use the same concept of what we just did, where y becomes -x. Well, if you take y is equal to -x, and I divide by -1, divide by -1, then that means that x becomes -y. So y becomes -x, and x becomes -y. So if my original point was at 2, 1, 6, 2, and 4, 5, when I switch and flip across this y is equal to -x right here, I want to flip across that purple line now, then what's going to happen is the 1 and 2 are going to switch, and they're going to change the signs of what they were. So my x value was -2. It becomes my -y value, and vice versa. So we switch them. So your x becomes your -y. So I take the y was 2, and the -y would be -2. And then your y becomes your -x. Well, x was 6, so my -x would be -6. And we do the same thing here. Your x becomes a -y, and your y becomes a -x. So your rule then is your x and y change to or yield a -y and a -x. Your x becomes a -y, and your y becomes the -x. Now, we can reflect across any line, like I said. So let's look at this one reflected across y is equal to -2. Remember, if you y is equal to -2 means where all the values of y are -2, so it crosses through the y-axis at -2. So y is equal to negative 2. So let's look at e first. E is up here at 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4. So e is at 7, 4. Now, I want to flip it across y is equal to negative 2. So we need to count how far off y is above negative 2. So e is 6 above negative 2. So it needs to flip and go 6 below that that line. So 1, 2, 3, 4, 5, 6. So your new image of e becomes 7, negative 8. Now notice my y value didn't change, but my x value, or my x value didn't change, but my y value did. So let's look at my f. This is my e prime. Now let's look at our f. So f is 2 below the new y line. Basically what we're doing is we're shifting our x-axis down, and we're pretending that we have kind of a new origin. So I'm 2 below the line of symmetry, so I need to go up and be 2 above it. And so my f prime is now at 8, 0. Again, notice that this was at 8, negative 4. Notice that my x value didn't change, but my y value did. Now, here's the tricky one, and we saved it for last. D is on the line, which means basically if you just put a dot on a straw and spin the straw, then the dot just spins around the straw. It doesn't change sides. It just stays on the straw. So D doesn't move because it is on the line of reflection. So it was at 4, negative 2, and it will stay at 4, negative 2. So that is reflecting across y is equal to negative 2. Now we want to take that shape, the image that you just got, the D prime, E prime, F prime, when we want to reflect that. So I want to take this shape right here, and now I want to reflect it across x is equal to 2. So here's x is equal to 2. Remember, it crosses through the x-axis at 2. So now we look at E. E is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 away from x is equal to 2. And so it becomes negative 3, negative 8 when you flip 5, 1, 2, 3, 4, 5 across. So there's my E. Now that's double prime because I've moved it twice now. My F was it was 6 away from the axis, so it will be 6 away from the axis on this side. So that is my F double prime, and it is at negative 4, 0. And then I have D, so D was the same as D prime, and it is 2 away from the axis. It will remain 2 away from the axis, and so it is at 0, negative 2. So sometimes it's easier to look at it on the graph so that you can physically count it. And sometimes if it flips across either one of the axes, or y is equal to x, y is equal to negative x, it's easier to use the rules. Remember, when you're flipping horizontally over the y-axis or over a vertical line, your x values are what is changing. When you flip horizontally or across a horizontal line, you're flipping vertically, then your y values are what it changes.